Oops. Okay, good morning. Would those at the door please close the door? And then maybe come to the front, yes. Thank you. Welcome to the core working group. I'm Carsten Bormann. This is Jaime Jimenez. This is an IETF meeting. We are at Wednesday in the IETF, so I think by this time you know the routine. Have you prepared a notes document? We're using the Etherpad, right?
Yeah, I mean the Etherpad is prepared, but we should ask for some. I
Okay.
have one note taker for now.
Okay, so who else wants to be note taker, at least for the part where they are not giving a presentation, maybe? There is an Etherpad for doing that, so you don't have to do all the typing. Can you do that, Christian, or are you busy preparing? Thank you. And please note the note well. As you may have noticed, we actually have a new RFC with updated IPR rules. So this is as good as an occasion as anyone to actually go and read that again. You may actually learn something new there. And there's a little bit more detail on this slide. And I'm putting the link to the HTML version of that up here as well. But of course, the actual relevant rules are in the RFCs pointed to here. And the very, very short version is if you are contributing something, talking here in the working group, and are talking about the technology where you know there are patent claims on it, you have to tell us, or you can choose not to talk about the technology. Okay, agenda. We have pulled up some of the, why does it say Tuesday? Sorry, today is Wednesday. It's going to say Tuesday about 10 more times on the slide. Oh, it's time warp, yes. So, I mean, just go around the Earth once and then it's still Tuesday. We have pulled up some of the material from Friday where we only have a 90-minute slot. So we will do a quick status update, look at 2 documents that are in the ISG right now, then look at documents that are getting ready for working group last call, and then there are a few things that have been pulled forward from Friday. We have a little bit of a difficult scheduling this time because there is a TLS meeting in parallel. So we had to push some of the things to Friday, and that's why Friday is pretty full. Alexei, you want to say something?
Yeah, I just noticed that the URI TCP protocol discussion has quite a lot of time. Adam asked me, is core working group going to discuss it? If yes, I would rather be present, but he needs to be in TLS. I'm not sure, how to accommodate his request, but
I don't think we can push this on
Right.
Friday because it's already so full.
Well, I think we have some kind of way forward from the discussions on Sunday. Yes. So if we try to stay more factual about it and just,
I think what what is on the agenda here is the working group needs to digest what came out and find out whether actually everything still works.
Sure.
That's the agenda item for today.
I think that's fine. Thank you.
Thank you. Any other comments on the agenda? Okay. So working group status, one RFC got published between the last meeting and now, RFC 8132. So we now have a few more methods in CoAP, the patch methods, patch and iPatch, and a method that is called fetch. That name rhymes nicely with patch, but maybe confusing to people who know about HTTP fetch. It's something that is called called search in HTTP. It's a get with a body for parameters. So that is available now, and that is actively being used by a number of things that are going on. A couple of advertisements. There is a DNSSD meeting this afternoon, and while we are only talking about the resource directory on Friday, obviously we have a strong relationship with DNSSD, so those who are interested in the resource directory probably want to be there. Tomorrow there will be a side meeting between the people who want to run Yang on the IoT and those who do Yang in other areas. It's quite interesting. The NetMod meeting was in parallel to the CBOR meeting on Monday. Nobody thought that maybe that there might be a conflict. Maybe there wasn't. But we want to coordinate better, and that's why we have a side meeting to do that. Tim.
Hi. Yeah, thanks for the advert for DNSSD. I'm one of the co-chairs. So we have an internet draft that Kerry Lynn, Peter van der Stok, and a couple of other people have written. So even if you can't make the meeting, I urge you to look at that. It's about mapping between DNSSD and Core RD. So have a look at that. And it's on the agenda towards the end of the meeting. So even if you just pop in for the last 20 minutes, you'll have to be able to take part in that discussion.
Thank you. Okay, looking at our own milestones, we are a bit late. We actually managed to do this milestone here, the color of which I cannot change in Keynote for some reason. I have to find out why. Anyway, this is interesting because things came up during the IETF last call that we want to talk to in a couple of minutes. Yeah, but SNML, resource directory, and the COMAI work are in this meeting, and I hope we make significant progress here. SNML will complete its working last call today, by the end of today, I think. So we might be able to clean this up a little bit more. Another interesting development, the core interfaces document has had some personal changes and now has had another round of personal changes. And now I'm quite confident that we will be able to make progress, but we probably only will be able to discuss them in Singapore. So expect something happening with the DIN link and the interfaces draft soon. So one of the reasons why this is complicated work, even though the drafts themselves are not so complicated, is that early versions of these documents have been picked up by other SDOs and put into their specifications. And we just have learned a lot from that. So it's probably useful to look at that again and see what the result is on those documents. Tim?
Hi, Tim Karinioka. I just have a quick question on some of these milestones that you have here. And I'm just trying to get an understanding of potential published dates, just to try to figure out what we think is going to be published this year and maybe what we pushed off in next year, because I get these questions, as well. So, with respect to the resource directory and the SNML, do we actually think that we're going to get something published this year?
Yes.
Okay, that's what I'm trying to get at, because I couldn't get it through some of the dates that you've got up here, right?
Alexei Melnikov, maybe chairs and AD should discuss updating milestones to just be more realistic.
Yes. Okay, just to give you my personal assessment here, SNML, I think we can process the working group last call comments on Friday. and then it will take a couple of weeks until the authors have something that can be pushed to the ISG. So this is very close. Resource directory, we had a pretty productive meeting this morning, and the authors think we now have, we now understand why it took us so long to get where we are, and how we can make this, how we can finish this quickly. So this will become evident on Friday, and this should go to working group last call maybe after 1 or 2 reiterations. And COMI, of course, is a set of documents, and we will talk about their status later, but at least one of the 4 documents is really ready for working group last call now. And the other ones, well, they do require some more coordination within the IETF, which is happening tomorrow. So I'm also confident that we actually can get all these documents through working group last call this year. They may not be published this year because there are steps after working group last call, but we should be able to process them.
I'm sorry, Carson. I'm just trying to figure out. Are we saying that the documents on this list, or just the COMI set, would probably not be published this year? I'm still kind of curious about resource directory and CenML, because we kind of use those back in lightweight MDM. So
yes,
I just didn't know.
Again, I think CenML is the most advanced at this point in time. So there are a few things that still can be discussed. Maybe the best way to handle those things is to just not include them and put them in as extensions. And apart from that, yeah, wait until this evening until we know all the working group last call comments, and then we should be able to process them on Friday. So it's really imminent. And the other ones are progressively a little bit more work. Resource directory, we have a clear direction, but have to write it up. And after writing up, we will get comments.
Right. So, but I guess my question is that for those particular drafts, are there, do we see any hurdles of actually publishing them this year? That's what I'm trying to drive at.
These will know.
Okay,
I think
that's what
yeah.
I just got mixed up when you were talking about the COMI stuff.
While COMI is a set of drafts, and some of them we actually might be publishing this year, and some of them might get into early next year. Okay, so this is about working group status. Now let's talk about the 2 documents that, from the point of view of the working group, are already published, but that have got an interesting discussion. One is links JSON. Just to remind everyone, we have this RFC 6690, which is usually referred to as link format, which does 2 things. It defines a serialization for web links, which are defined in 5988. And it also profiles 5988, where profile is, well, a bad word. So, yeah, we took 5988 and took what we liked, and maybe ignored what we didn't like a little bit more than we should have. Anyway, so this document has been out there a long time, has been the basis for a lot of work in other SDOs. And now it turned out that it's useful to have JSON and CBOR serializations apart from the text-based serialization that 6690 provides. So this is what links JSON is about. And now the comment that we should have thought about, but didn't, was, well, this is a 6690 serialization. Can we use this as a general 5988 serialization? And the answer is, So we did some things in 6690 that are a little bit icky for that. One is we essentially disallowed percent encoding. So we would have to define for this serialization what semantics percent encoding would have. And the other thing we defined a few default values for certain elements of a link. And we might want to look whether we can make this work in the general case, so people who don't want those default values can do something different. So that would be a change. It would not be a big change, but it would be a change that we would want to coordinate with those SDOs who have picked up the links.json work already. So this is one area of work. Now, the problem here, or maybe the fortunate thing, I don't know, is that 5988 this is happening. So 5988, which had a couple of places that were really not very well defined, is being revised, and a number of bugs or potential implementation snags are being fixed, and a number of clarifications are made. So what is called link attributes is now called target attributes. So it becomes much clearer that all those attributes you put on a web link are really not about the link itself. They are not labeling the vertex. They are labeling the target. So this is much less confusing. There's another thing that's happening there. The new version explicitly disowns the namespace for the target attributes and says the owners of serializations should coordinate the namespace. And I think that's a really useful clarification, because we were kind of pushing forward and backward the responsibility for managing that namespace, and it's now clearly defined the management is in our court. This is still an individual draft, so the consensus process has not completed. But if that actually happens, we probably should do that. Alex?
I just put the document on NextIG telechat in 2 weeks. So
great. So
if you have comments, you better
I have
give them to me soon.
Them, but yes. So I think my comments are already addressed in the current version of that. So that's wonderful. So this means we really get a stable way to stable basis to operate on here. But this, of course, also means this is the time where we have to rethink a few of the 6690 assumptions. Really, we should be respinning 6690. I'm not sure that's actually necessary. But we may want to do a few things maybe in the links.json document that react to this. So coordinate with 5988 bis, which means we will watch that next telechat very closely. And on the other hand, coordinate with all the usages of links.json and the resource directory, which is kind of a variant of links of link format or links.json on steroids. Coordinate with those users and variants, and coordinate with other SDOs. So lightweight M2M is using a form of the resource directory. OCF is using a form of links.json. And there's just a lot of people we have to talk to find out whether we are doing something stupid. We might define this target attribute registry. We will probably discuss offline whether we do this in links.json or in a separate document. If we do it in links.json, it becomes an updates relationship to 6690. And when we have made all these changes, we probably have to decide whether we pull this back and do another working group last call and submit it to the ISG again, or handle this within the ISG process. But before I form an opinion on that, I would like to understand how many changes do we actually get there. So this is my plan for working with this document. And again, this is formally in the ISG now, but of course the working group should pay close attention because there are so many things that depend on this. Any comments on this? I see one person nodding. Okay. Good. So if you do have comments, please send them to the list so we can make sure that we do the right thing. Okay, next item, CoAP over TCP, TLS, and WebSockets. I'm always abbreviating this as CoAP TCP. There are other people who are abbreviating this as CoAP TLS, maybe a little bit confusing. Now, this document has received ISG processing, and one big comment was the way we are handling URI schemes is not good. So we pushed this to the ISG as -07, as version -07, and we had extensive discussions about how to handle multiple transports with URIs, and came up with a solution to have one URI scheme per transport. That's not something that anybody in this work group particularly likes, but it came up as the least worst solution that we could come up with. Now, of course, we are not the only people with that problem. So while we are going through the URI review process, OPC UA came in with very, very similar requests. They also have 3 different ways of referencing OPC UA resources, and they were trying to register 3 URI schemes as well. So it has become kind of obvious that maybe there is a bigger problem there. And when we have a bigger problem, we call in the Internet Architecture Board, and I'm giving the microphone to Dave Slater,
who has now managed to escape from being Internet Architecture Board. Okay, so I actually wrote a draft in between last IETF and this IETF, and there's the name of it if you're looking for it. So I gave the presentation art area on Monday, and I'm going to be giving a slightly different version of that topic and gloss over a couple things that are outside of core and go deeper into things that are specific to core. So as Carsten mentioned, just between last IETF and this IETF, there's sort of been 3 different discussions going on, well, 2.5 discussions going on. There's the OPC one, which is the 3rd bullet that Carsten was just talking about. There's ours, which is the 1st bullet. And then OCF had a liaison message that came and said, hey, we like the schemes in 07, and if the IETF is deciding to not register those, then the OCF will just register them provisionally. And since draft 09 then appeared and OCF didn't get an answer, those schemes are now actually registered, the ones in the top bullet are actually registered right now in the ANA registry as provisional, and they're registered to OCF. Now, the message from OCF said, and if you want them back, you can have them back. Okay. And by the way, the process for URI scheme registration, which is RFC 7595, whose editor is me, actually defines a process. If the IETF wants schemes back, you can do that even without asking the organization. So in other words, there's ways to do it, but OCF would say, yes, if IETF wants them, please. The only reason OCF registered them was because IETF seemed to be saying that they were not going to. Okay. So anyway, because of these 3 things, there's all kinds of emails on various mailing lists, such as URI Review, which is the mailing list that was tasked with reviewing requests for permanent registrations, which originally both core and OPC were asking for permanent registration, right? OCF was asking for provisional if and only if IETF didn't do it themselves. Because provisional, you can do anything you want. However, the IETF, for standards, must do permanent, right? We don't have the option of doing provisional. Any other SDO does, but we don't. All of our standards must be permanent, which is we have to follow our own rules. Okay, so I wrote this document to collect the different ways that people were doing things, because this is not a document that was focused just on core, because as Carsten mentioned, this is a common problem. And so there's different people do things different ways, and so it surveys a couple ways people are either already doing things or are proposing to do them on the list, and it points out the advantages and problems with each of those approaches. Okay, and some of those came from the core discussion, some of them came from the other discussions, and references to even older discussions. Right. All right. And so there's a couple documents, such as, the W3C has a document. And so one of the basic principles that the IESG mentioned and the W3C mentioned was this notion that a resource, as named by, say, an application, should really have one canonical URI that's independent of how you get to it, right? So if the IP address changes, you don't have to change the URI, right? And in this case, if the transport protocol changes, if you're using UDP versus TCP, if it really is the same resource, if you can name it the same thing, right? That's the advantage, or that there's an advantage of that. And so there's documents that talk about that. So an example of why that argument is there is in the web architecture, things like links are used to say which resources are more valuable than others, right? This is one of the arguments that's made in the architecture of the www. It says, and so in order to value something, you have to count how many in-links there are, how many places there are that point to it, right? And if they don't all point to the same thing, it messes up your valuation, right? So it's an example of the style of things. Similarly, you can make the same argument in like 3986, which has different ladder levels, right? Which is, how do I compare whether two URIs are equivalent, right? As well, there's multiple different ways. Do you just compare the string, right? Do you take care of other types of things like dot resolution? Do you go all the way down to saying, is there information about that's specific to the scheme, because every scheme can have different rules? Or do you actually resolve it and see if they point to the same content, right? So the point is that there's different algorithms specified in 3986, and that's what we mean by ladder levels. Okay? And so it is absolutely legal to have multiple URIs that point to the same resource. Okay? But there's a reason to minimize that, and so we'll talk about that. Okay? Now 7595, in order to get a permanent scheme, it had a list of requirements. Okay? The list of requirements in that RFC does not include this topic. And so the interesting thing that happened was to say, well, is this something that is a blocker for this document or not? And that's what actually generated some of the process discussions, let alone the technical discussions that slowed this down. Okay. All right. So now I'm going to talk about one thing that is specific to core and its relationship to OCF. And I think we even have a joint meeting in Singapore, right? Yeah, which is the Saturday preceding the Singapore meeting is a joint meeting with OCF, right? Because OCF is one of the top users of the core documents. And so I'm going to talk just a little bit because there was 3 different use cases, and it's helpful to understand what OCF's use case was because it illustrates some of the points that people are making on the list more generally. And so in the OCF case, there is a higher layer API that's independent of transport, and there's an example on the screen. It's OCF colon. It's not one of the ones that comes out of the core working group. Okay. And so the people that say, well, you should just be using one common URI that's independent of transport, well, OCF does that, right? It's hash a public key / whatever the rest of the URI is, okay? But you still need a way to get the actual transport endpoints, right? What's the actual, host name or IP address, or what's the actual port number? What's the actual transport protocol? Is it TCP, or is it UDP, or is it WebSockets? Is it TLS or not? Okay. So you still have a way to resolve those, or to learn those. Now, some transports that we work over, like WebSockets, already uses URIs as the way to name endpoints, right? It's not a port number. You have to have something in demux, and this was shown in draft 09, right? And so for consistency, OCF found it convenient to just use URI format for all the transports. And so the schemes that was in draft 07 was great for that. I added a slide on that's the next one that will show an example. Now, how you learn that might be via some lookup step, which is take this URI, do some step to resolve it to some transport identifiers. Or it might be, however you got that URI in the first place, you also got the other information that came along with it, right? Similar to when you're resolving a DNS name, or when you're resolving a name through the DNS, you might get back some additional stuff in the additional records section, saying, you might need this too, right? So there's different ways to get it. Now, in theory, this could happen at multiple layers, right? If you have some application layer protocol that sits on top of something else, and that sits on top of something else, and in each of those is a fork, and there's multiple possible things at the next layer down, it can be really complicated. We just hope that is really rare. Okay. Draft 09 started introducing that case, as you'll see, but Draft 07 did not have that case. So here's an actual example for those of you in front or that can bring it up on your own screen in the back. This is an OCF example where the red is the top level API. You can see here it's split into a base URI and a relative reference that goes along with it. This is their link format because they forked a link format a long time ago for reasons we won't go into right now because that was sort of before the time of Michael and me. And so the red layer is what the application is supposed to use, right? And so that's the one that doesn't know anything about the transport, okay? But when you get back those links, you're getting back the blue along with each one. And so the blue contains a list of transport layer links, okay? So for example, in the first one, it's accessible only over CoAP-S. And the second example, actually all three of the other ones, is accessible over CoAP-S and CoAP-S plus TCP, okay? So the point is those aren't really supposed to be used by the applications. They're just used by the protocol stack to say, here's how I get the transport identifiers, okay? And so this is why OCF said, yes, we really like this because it compresses stuff into one layer. Because you can see they can only go one layer down. This is a single array, right? This isn't a tree of stuff, right? And so if this was saying, this was CoAP-S, and you got to go another layer down to get the WSS colon that was in draft 09, OCF said, well, that doesn't work for us, right? Because we can only do one level of stuff. But if you have these, it works great. And they already submitted their draft as to ISO as international standards. So they're past the point that they can make a change right now, which is why they went ahead and registered them as provisional. Now, could they do something different in the future? Possible, but for this version of the standard, that's already locked. Okay. So this is just an example that shows an upper layer URI and lower layer APIs. You can think of this being like an ID locator split where the locators are being transmitted in the syntax of a URI. All right, so now to finish up the sort of the conceptual things, there was a number of discussions that sort of convoluted, and so I try to tease apart the notion of discovery versus selection. Okay, so discovery is I have to get back the set of possibilities, okay? And selection is once I know the set of possibilities, how do I choose one, right? Do I use a happy eyeball style algorithm? Do I use something else, okay? So most of this is not about the selection algorithm, although that's what a lot of people want to talk about. That's not the purpose of this topic. The purpose of this topic is how do you get the list to be able to choose from, whether it's a selection or a happy eyeball style or whatever. Okay. So if you want to talk about selection, that's at least out of scope for the main question. Okay. Even though there's a whole section of the document that I added because everybody wanted to talk about it, so I captured that too. Okay. So there's 4 possible discovery approaches that I've seen. Okay. The first, and of probably the last 2, means the one on the next slide, are the ones that are the most relevant to us. And so these I'm going to gloss over fairly quickly unless people have questions. The first one is the document that specifies the URI scheme, specifies it, and you hard code it. Right? TFTP is an example of that. You can read the bullets. Second example is you take all the information that you need and you encode it into a single URI. Right? So if you support 2 transports with different port numbers somehow, or a service name that's accessible over 2 things, you encode that all in the same common URI. Yeah, that's really ugly. Okay, next one. All right. Number 3 is a set of URIs, 1 per transport stack. Right? That's what draft 07 did. Okay, that's what this working group had consensus on at the time that it was submitted to the IESG. Right? This, of course, results in there being multiple equivalent URIs. Right? Multiple URIs that point to the same resource that differ by, say, URI scheme, and maybe by things in the authority component, such as, you know, a port number, if there's a port number present. Okay. Now, because of that, this often results in the need to have a higher layer API, higher layer URI, such as the OCF colon in the OCF case, right? OPC, on the other hand, does not have one of these, right? And so I think a number of the discussion along the IESG and on the list in response to the draft 07 was, well, you're missing this thing, right? And OCF said, we're not missing it. We'd like draft 07, please. Right? Okay, so that's kind of how that went. Now, this works great unless, of course, you have complex stacks with multiple layers. So for most purposes, this is okay if you have a higher layer one and a set of lower layer ones. But if you could ever have a tree of stuff, it gets more complicated. And we hope that doesn't happen very often. And the only natural place to have multiple transport URIs, so 1 per transport stack, is to vary by the URI scheme. Yes, there's other places you can wedge that, and the draft covers that too. You can wedge it into various places, like in the authority, or using the port number as a hint. And there's a nice document that was in this working group that covered a number of those possibilities, and this is the more sort of non-core specific draft. The last category was also discussed, again, on the URI review list, which is, why do you even want to use a URI format for that, right? So if you go back to the example here, right? I get why paraphrase, I get why the red is a URI. Why is the blue in URI syntax and not some other syntax? Right? Those would be sort of from the W3C that says, well, those things are sort of following the architecture of the World Wide Web. You should be something other than URIs for that. You're kind of messing with our URI stuff, right? And so that's category 4, which is using a format other than URIs. Okay. Now the disadvantage is that if some of those transports, URI is the natural thing to use, such as a WebSocket. And other things, say raw TCP sockets, there's no URI scheme for a raw TCP socket, right? And so well, no, there isn't. You're looking at me weird. There's no TCP colon today registered. Okay. There could be, right, but there isn't. And so the disadvantage is if you pick something other than URIs, you have to define some format or agree that you're not going to have consistent ones across transports, right? So if you have some application layer protocol that could be using WebSockets and TCP and DTLS over UDP, say CoAP maybe, then you'd have to define some other common syntax or define a way to carry things in multiple syntaxes. And so URIs happen to be convenient for that. Okay, and so the advantage of 3 over 4 is just you can use a common syntax that exists. Okay, but that's the debate between 3 and 4. Just to put it out there, right? That's a sort of a well-known debate now. So those are the 4 categories. And the last slide was specific to art, which is that particular draft. And so at this point, okay, that's the overview. And so I guess I'm going to hand it back to Karsten to, you want to cover this or do you want me to moderate this, which is what do we do in the CoAP TCP document, right? You want me to hand it back to you? Yes. Okay.
But of course, it would be good if you would exert your moderating. Yes, please.
Stuart Cheshire, Apple.
Excuse me. One thing quickly. Etherpad seems to be down right now, and we want to have good nodes of the discussion. So could the note takers just type locally for a couple of minutes until we get something like Google Docs or something set up to. Yeah. Yeah, I have a few more slides. Stuart, now, please.
Stuart Cheshire from Apple. It might be helpful to jump back to slide 19, if you can do that. I will confess to some frustration about this whole process. I've basically ended up devoting most of my adult career to working on service discovery. I didn't plan that. I thought I would graduate and go to Apple, do that a couple of years and move on, and it turned out to be a bigger problem. One of the points you raised, Dave, is about the port number, which has always been this historical anomaly, I would argue a mistake in the IP architecture. In Apple talk, names name these tuples, which are net, subnet, host, port, and they take you all the way to the target process. In the internet, a typical DNS name is a host name, which gets you to a piece of hardware, and then we go, oops, we forgot to specify what endpoint on this hardware, and then you tack :port on the end of the name. So the pain you describe about how do you cram the port number into this, you don't describe the same pain with how do you cram the IP address in, because that's looked up by the name resolution mechanism. And I know you know this well, Dave, with DNS service discovery, that's why we used SRV records, because SRV records remedy this omission that the internet historically left the port number out of the resolution. I wrote RFC 6760, which is sort of the requirements document, and there's a section in there entitled, I think, Escape the Tyranny of Well-Known Ports. And it's very frustrating to me that I wrote this up 15 years ago, and yet we're still having years of soul searching and navel gazing, worrying about how to solve this problem. I'll let you answer that first, and then I have a second comment on this.
So I think I had 2 or 3 points. Let me see if I can keep them in my head. The first one is that the discussion around service names is actually one of the topics in the draft, and one of the things that I complain about is the fact that you can't put a service name in the URI. You can only put an integer where the port number field goes. Okay, that is one of the problems that causes some headaches, right? The hurdles that people try to jump through in making proposals to stick in a service name someplace are convoluted, to say the best.
Which is incidentally addressed by your comment that why does this have to be a URI at all?
Yeah. Second point, in the examples that are used in the link format, whether you're talking about the link format used by OCF, the link format used by the IETF, okay, you can see here, there in this particular example, right, if we looked at a core links example, you'd see something similar where the links here are including IP addresses, not DNS names. And you can say, well, why is that? Okay. Well, it's because they don't want to have to go through an extra step of DNS resolution, or even MDNS resolution for that matter, because this will work even if it's not on link and there's no ability to register in a DNS server. However, then you can say, well, why didn't you just use DNSSD for this whole thing? Okay.
You could say that.
And the answer to that, my understanding, because this is for constrained devices, and constrained devices already have to support a particular protocol to access the resource. And so if they have a fixed amount of code space available, then implementing two protocols, one for discovery and one for accessing the resource, is more expensive than having one protocol that does both. And that's why they did this.
Yes, I'm familiar with that argument, and I think I'm unconvinced.
One additional comment here. Now, there's another subtle difference here. This is about resource discovery and not service discovery. And there's another fine point, I think, that we need to pick up. So we have hosts, we have services, we have resources. And
now, could you, in theory, use service discovery for doing resource discovery, which is another level down? Could you, in theory? Yes. Do people now? No. Could they? Yes, other than the constrained argument. Right.
I would be happy to engage in discussion about that, because I know we've talked about this before, and people in the KERP community make this great distinction that a resource is different to a service.
Now,
and when I look
right
at
now,
it,
the main argument is not that one. The main argument that I have heard from people, right, because I'm an IETF person in other communities, right, the main argument that I've heard from others is we don't want to have a DNS, which includes MDNS, implementation in these tiny devices.
let me very briefly tell a little anecdote. In the early days, we had these developer workshops at Apple where developers would come in, a bit like hackathon, right? They'd bring a laptop and a board and we'd work on code. One of the ones I remember, little device, you can still buy it, it's called Site Player Telnet. It's a little box the size of a deck of cards. It goes from Ethernet to serial ports. So if you've got some old device on your network with a serial console, you can plug this dongle in and now you can telnet to it over Ethernet. This thing has 16 kilobytes, not megabytes, 16 kilobytes of flash memory. 9K of that is the HTML text for its web-based UI, and in the remaining 7 kilobytes, he's got everything else: Ethernet driver, ARP, IP, DHCP client, telnet server, web server to serve the UI, whole deal in 7K. He came to this workshop and said, I have 900 bytes free to implement multicast DNS. And by the end of that afternoon, he had this thing advertising both its telnet service and its web UI using multicast DNS in 900 bytes. And that product is still on the market today. And it still has 16K of flash memory in it, and it still does all of these things. I've got a couple of them in my house to connect to old legacy gear with serial ports. So I think in today's world, if you don't have 900 bytes of code space left, then yes, I buy the argument. But anything that's got more than 900 bytes of free code space, you can do multicast DNS. Anyway, that was the anecdote. The comment on this slide, which I think you alluded to, Dave, but I wanted to elaborate on it, because I have come to realize this is a more subtle issue. People who used AppleTalk sort of read the docs and got this ingrained in them, but most people in this room, I actually bet nobody in this room has done AppleTalk programming apart from me. So in, oh, I'm...
For those remote, that was Kerry.
Okay, nobody apart from Kerry and I. So to address that, there's a brand new 0.0 draft I submitted for the DNSSD, which is the roadmap document. And I would love to get feedback on that. It's a pretty short document, but I tried to outline some of the principles. And one of them is many service discovery protocols, and this includes SLP and UPnP, SSDP, and things, they conflate two steps, which I think are different. And what I'm talking about there is discovery as opposed to use. So in the discovery step, you say, and I'll use the boring old example of printers. In the discovery step, you say, I want to print, show me what my choices are. And here we have the terminal room printer. In other places, you might have 5. At the point of choosing which one to use, you don't need to know the IP addresses of all of them. You don't need to know other details about them. You just want to know enough for the human or the software to make a decision. So the discovery step is a lightweight operation that gets a brief summary of each service on the network. When you've picked one to use, that's the step when you need to know the contact information, the address and the port, and maybe other details about it. And in the example of printing...
I don't believe that.
Which part do you not believe?
The part where you think that selection can be done without knowing whether you support a common transport.
That's a philosophical debate, I think, about when you define a service as being this package of protocols, like how much is included in that bundle, I think is a question of what you think to be the service.
I gather that you're arguing that discovery can be done with blue. Pick which blue one I'm going to use. And this is an example where all the blue ones are different, but pick a case from a resource directory. You have a bunch of blues on different servers or whatever. Right. So I'm going to pick the blue one without having any of the red information. Okay. And even if there's ones that are mandatory to implement, that doesn't mean that it's actually in use by that particular server, right? So let's say one is v4 only as a server and one is v6 only as a server, right? And if you're a v6 only node, you can't necessarily talk to the v4 only one, right? I'm just picking an example that many of you can relate to, even though it's not the one that would be the most likely.
Right, and I think maybe where we disagree is whether it's necessary for the discovery step to do this very precise filtering that you can't discover things that you won't subsequently be able to communicate with. Because if you follow that logic to its conclusion... Yeah, you can
absolutely discover things. The question is, you are talking about selecting before doing the discovery of the actual transport information. And that's what I'm responding to.
Right. And the reason I'm saying that is that the transport information may change from day to day. And I'll go back to this printer example. On a laptop, forget iPhones and iPads, but on a laptop, you typically go into system preferences, you click the plus button, you see a list of printers, you select one, you make a print queue for it. That is the selection phase. After that, for a typical user, they set up the printer once when they get it, and every day after that, they hit Command P and print. They don't need to browse the network to find the list of printers. They know the name of the printer they want, and they say, how do I connect to it today? And its DHCP address may change from day to day. If it's using dynamic ports, the port may change. If it gets a firmware update, maybe yesterday it didn't have v6 and today it does. So the details of how you connect to it change over time. The selection, especially in the case of setting a print queue, is sort of a once-in-a-lifetime thing. And to conflate the once-in-a-lifetime thing with the daily thing, I think is missing some important distinction there, both in terms of efficiency and functionality.
I'm trying to, I mean, we should let Carrie probably speak. I'm trying to up-level that to try to figure out what the point is for the core working group to consider as to what we should do. Right? So I don't know if, Carrie, you have a comment, but I know you've been waiting for a long time, so.
Yeah. Maybe just one comment. In this working group, we are kind of used to people coming in and saying something based on experiences with processes that involve humans. And in our case, often we don't have those humans. So it's sometimes hard to actually transport those experiences over to our work.
Carsten, with respect, this is an argument I've heard 100 times in many different situations, that the Anima working group gave me exactly the same story, which is we need a service discovery mechanism to discover things on the network, and we can't use Bonjour because that's only for humans. And that is complete nonsense. I don't know where this myth originated. I'll give you one example of something that is 10 years old now, the Bonjour sleep proxy, which is what lets your iMac go to sleep and still be doing printer sharing and file sharing and screen sharing, even though it's gone to sleep to save power. When it goes to sleep, it looks on the network and says, I'm going to sleep. Is there a sleep proxy that can act on my behalf while I'm sleeping and wake me when I'm needed? It discovers that sleep proxy using Bonjour. The service type is sleep-proxy._UDP. It does a browse, typically wireless base stations, Apple TVs, anything that's low power and always on is a good candidate for being a sleep proxy. So you may have 4 or 5 on your network. The iMac going to sleep will do a browse, find them, make a determination which one to use, connect to it, transfer its records, go to sleep. We've been doing machine-to-machine serve discovery for 10 years, and I keep being told Bonjour can't do machine-to-machine, it's only for humans. And I have no idea where this myth came from.
Carrie Lynn, I think I had 2 comments when I came up, but now I've got 4 or 5. So first comment I want to make is that I agree that not all resources are services, but certainly something that looks like a RESTful API endpoint, I think if we squint, we can probably see that there's some rough equivalence between that and what DNSSD has traditionally called a service. And later today in DNSSD, I'm giving a brief presentation on how to map between those 2 systems, between those 2 naming systems. Number 2, I just want to mention something historically, which was what that Cullen Jennings proposed at one point, a scheme called HTTP plus SRV. So I'm not sure you meant to say we can't represent service names in URIs.
I didn't. There's plenty of places you can try to wedge it in there, and I talk about a couple of them in the draft.
Okay, great.
Right. For example, right, you can have underscore service name dot underscore TCP dot rest of the host name in the host portion of something if the scheme defines it that way. Right, that's legal. You can't take an existing scheme and retrofit that, well, in any interoperable way anyway. But it's absolutely possible, and that's in the draft. But that's an example which actually embeds the actual transport in there because the underscore TCP is in there in that example.
Okay, the third thing is, I think one thing that might have gotten lost in a comment that Stuart made, which turned into the selection discussion, is that I think the dominant paradigm for discovery is that you know ahead of time what you're looking for, whereas maybe in a very small percentage of cases, you would want to go to a device and say, okay, what can you do?
Yeah. Both are use cases in core, absolutely.
Yeah, but the latter I think is really in the minority.
It's a case for pretty much every device, but not every use case of that device. So,
Okay,
for example,
well,
your security configuration tool for every device needs the ability to do that.
That's about the one case where I can imagine, that it's useful.
Yeah.
And the fourth point is that I think the response can potentially be driven by information that comes in the request. So there was a draft that I was responsible for a long time ago called XMDNS, where we were looking at expanding it, to a larger scope, the larger multicast scope, and essentially we used the type of address in the source field to drive what came back. So if it's a global address of the sender, then you respond with you don't include the link local address, in the response because obviously they can't do anything with it if they're off link, or you assume that they're off link, and so that information is not particularly useful and just wastes bandwidth. So that could also help in the selection process.
So Tim Carey, Nokia, just a quick comment on Stuart's stuff. I will say that for some other SDOs that are doing IoT, they actually use DNSD for discovery. We don't necessarily have the constrained pieces of it, but it's interesting to note that if you can put an MDNS in 900 bytes, you guys might want to consider it. Now, as to this, my question is, and I understand the pressure that you're feeling, right? Because we're trying to get this thing out, right? So my pragmatist and my business hat on, I'm like going, man, we got to get this thing going. The question I have is that outside of that, Isn't the draft that we have for protocol negotiation solve this problem?
Are you talking about a COAP draft?
Yes.
Yes.
If you look at this one right here, okay, so if I take a different example than the one that's on the slide here, it's still an OCF example, okay. Look at the second blue line where it says COAP S and COAP S plus
I am.
TCP, right? That one is, let's pretend that that one said COAP S and HTTPS. Okay, now tell me how your protocol negotiation one solves that. If the answer is yes, it does, then
the
yeah.
protocol negotiation draft,
Yeah.
as I understand the draft, and I guess we'll have a presentation on that soon, so someone probably might understand it better than I do, but it's supposed to be where the client and the server can negotiate the alternative transport sets. And so part of that is the
Yeah.
discovery component. And so I'm just, my curious is it
Right,
says,
I think an
I understand that
HTTPS
this
is the
might
alternative
be, this,
document there.
and we have pressures,
Yeah.
but does that solve this open issue that we've got ourselves in my, so my business side is like, hey man, let's go make some money, right? My engineer side says, am I in a corner? Have I painted myself into a corner, right?
So we will have a couple of minutes to do that part of the discussion. Right now, we are still at this end.
Well, so it comes
So-
back around
so I can
to
answer
say,
your
are
question
we
now, I
making the
think.
wrong selection?
Yeah. I think I can answer your question if it's equivalent to like the alt-serve document that's in HTTP BIS, okay? Which is if I understand right, you open up a connection across one protocol, you ask it for its alternate transport, so now you get it. So there's a discovery step that says, I contact the machine and I ask it, okay? And so, yes, that's solved at the disadvantage of being an extra round trip that slows down latency and increases bandwidth compared to, let's say I got this from a directory, whether that directory is a resource directory or whether it's a DNS server or whatever else, okay? If the stuff came back from the directory, using the term generically, right, then I wouldn't have to have as many round trips to do the negotiation, right? So does it solve it? Yes, but it's got some downsides.
Okay. So the problem is that I can hard code everything, if you will, right? Or I can
Learn
actually
everything
do,
and- yeah.
or I can, and where does it sit between? So I'm
Right.
unconvinced that, I'm unconvinced that round trip isn't necessary, right?
So what we've seen going back outside the scope of just core, right, is that different SDOs and different applications have a variety of use cases, and it's very difficult to come up with everybody should do it the same way. And so whatever way we agree on, there's probably going to be some SDO out there that's going to do it some other way anyway. And so the topic of this is to figure out what we do with the URI schemes, right? What the IETF will do with the URI schemes, right? We can't necessarily control what other SDOs or other proprietary implementations are going to do, but we can control what we're going to do in the IETF, okay? And so is the IETF going to have URI schemes? Is it going to have URI schemes that are sort of locator level? It's going to have URI schemes that are sort of ID level, or is it going to have URI schemes that are kind of both? Okay, that's a decision we can make that can control our own destiny. We can't necessarily control what other people do.
Right. So we have used almost the entire space we have for the whole topic, and we are just in the first of three. Yes. So Stu, can you make a quick comment?
I'll be really quick. I was just struck by some irony here. Looking at this slide, there's like maybe 25 lines, average 40 characters per line. There's about 1,000 bytes of text there.
It's
So
because it doesn't appear this way on the wire.
the text on the slide we're discussing is bigger than the implementation of multicast DNS service discovery that's in the site player telnet.
Right. What's
I-
shown on the screen is JSON. What appears on the wire is CBOR, for example. So yeah, it's not representative of the number of bytes.
But in terms of the number of bytes, it's a very verbose representation.
So maybe one clarification when you talk about those 900 bytes, that's an MDNS advertiser. It's not an MDNS implementation. Thank you.
It doesn't browse for services, it only
Thank
advertises
you.
for services.
I don't think that's the main question that we're talking about. It's useful background information, but it's not the
Yes.
main question.
Right. Okay, so I think we finished this segment.
Yep.
And now let's focus back on what this working group has to do. So
You want me to
if
sit
you
down
want
now
to
or
sit
stand?
down, if you want to sit
You tell
down,
me.
that's fine. That's fine, I think. So just to remind people, the -07 that we gave to ISG had three UI schemes. I mean, one was defined in 7.252 already for UDP, and it added the TCP and WebSocket version. I'm going to not say all the same thing again happens for CoAP S every time. So always think that we have another set for CoAP S. So in total, 07 left us with 6 URI schemes that can be used to talk to a CoAP server. Now, we talked about those ISG concerns, and what the authors tried in -09 was to simply define one URI scheme that maps to all 3 transports. And I think we have heard why that doesn't work so well. So the compromise that is now currently on the table is to revert to -07, but also to add a 4th pair of URI schemes that does have some form of transport discovery in it. Now, that's a wonderful way to solve the impasse, but it also leaves us with a little job to do, which is to define that 4th scheme. We have to define the rules for this thing, which I called CoAP plus AT after the suggestion of Bill here. So all transports. So this would be a URI scheme that is equivalent, URI scheme URIs of which are equivalent to the CoAP, CoAP plus TCP, and CoAP plus WS forms. Now this is a little bit weird because we have an equivalence between the AT scheme and the transport-specific schemes, but it's not quite clear that we can simply stipulate an equivalence between the transport-specific schemes. Maybe we can do that, but I think a little bit more thinking is needed here. So for instance, one thing is the CoAP protocol has defaults for the URI scheme. The URI scheme is actually rarely transmitted in CoAP, and we have to make sure that the default we take is actually the one that we should be taking. So there's a little bit of work to do here. Barry.
Hi, this is Barry Leva. Is the intent that CoAP plus AT would eventually become the scheme you used and you'd stop using CoAP?
Dave Taylor. My belief is that the intent would be to be the same as OCF's intent of the OCF code, which is a thing that applications should use. Unless you're some really low-level application or something like that, that most applications would use CoAP plus AT and be completely oblivious to which transport scheme it was, or what other locators, what the port number, what the IP address, or whatever else. Yes.
Yeah, so that's one way to view it. Another view is that the area where we need these additional transports actually is a niche within the CoAP ecosystem. So we will still see a lot of use of the UDP-only scheme, because that's a very normal way for a very constrained device to operate. But the fun part is we could define multiple of these encompassing URI schemes. I mean, OCF already has one. So we're just adding one, and then a third organization comes there and adds another one. So it's not necessarily the case that the CoAP plus AT would be the one that is most widely used in the end.
So Dave Saylor, nobody asked the question, so I was asking myself in my head, if CoAP plus AT were defined, and let's pretend that it was even in draft 07, would OCF use it? And I suspect the answer is depends on how you define it, bordering on no, but not necessarily no. And the reason was because the OCF scheme has multiple transports right now, which include the various CoAP ones and the various HTTP ones. And so if you have a resource, it's the same RESTful resource, and it's available over, say, CoAP with one or more transports and HTTP, then would you be able to use the COAP plus AT scheme or not? That depends on how you define it. If the answer is yes, then in theory it's similar to what OCF did, okay? At least subject to this. There's a different constraint as well that I won't go into right now unless you ask, which I'm happy to, which has to do with the security stuff. And so we'll get to that in probably in another might comment or two probably. So I may come back to talk about that. But here, the question is COAP plus IT, is it inherently COAP specific or is it not inherently COAP specific? And I'm thinking about the alt service discussion here that says, okay, can you do protocol negotiation and find out there's an alternate service over HTTP? And if so, then maybe you define this as not being COAP specific, and then it would be more generally useful to other organizations. So just a thought.
So the reason I said that Dave's answer previously was what I was hoping to hear was that I look at this as we painted ourselves into a corner that we didn't know we were in when we did COAP. We are now getting ourselves out of that corner with COAP plus AT, and I would like to see us move toward that. And now Karsten said, oh, but if you know you don't need the new features, then you can still use the old one. I would really prefer to see us move rather than have both of them actively in use. Although the other side of it is, you said often that the scheme is not even used because you know what you're doing and you don't actually pass the URIs around, which is different. But I think if we use the URIs and we do this strange mechanism, I'd rather see us move to it rather than leave the old one as recommended still. And obviously it's going to exist and people can use it, but I'd rather it not be the one that we recommend using.
So I'm going to try to jump ahead and give my current leaning as to where I think we should go. My current belief is that it's going to take a while to do the details to be worked out. And that, so my proposal would be the details to be worked out be in a separate draft than the current draft, and that it contain a sort of a forward reference to say, that, left for future work is the following requirement that needs to be done. Okay, and so the details of what COAP plus AT is in a different document such that you're defining the things that applications aren't supposed to use here, and then the things that people are supposed to be using in a different document. And that's because things like OCF and other organizations already have protocol implementations of the COAP plus TCP protocol. And if you are not using the URI scheme as your syntax for the locator, then you don't actually care about this discussion, right? And so you don't want to slow down the protocol stuff going to RFC for people that don't happen to be, OCF is using URIs as the syntax, but other people don't have to, right? And so that's why I would propose that we could decouple and put into a different document, and saying left for future work is great. So I kind of think that's where I'm going, which means that the details to be worked out, there's not as much urgency for, and we can take our time and get it right, and we don't have to answer it, say, all in this meeting, okay? Yeah, and Barry is saying he would like it to be a document that updates this one. I don't have a preference either way on that one. I think it could be done either way, but if Barry's, I have no objection either way. And so the types of things that are part of the details to be worked out, okay, I'm just going to say an enumeration of such sorts of details, right? I don't know if you have a slide on that, but the things that come to mind is you have to have a way of sort of discovering the relationship or learning the relationship between a particular COAP plus AT and a set of other transport locators, whether they're those URI schemes or some other format, right? You gotta have a discovery mechanism. Is it updates to the resource directory document? Is it updates to the link formats document? Is it how to use DNSSD? And so on. I think that's gonna be a bunch of discussions. How do I learn that? Second part has to do with security. This is the part that I said I'd come back to the mic about. One of the things in the architecture of the WWW that it actually encourages different URI schemes for is when you have different security semantics. And so if you have HTTP and HTTPS, right, you want those to be set. So it makes this argument that that's actually a good thing. And so I think there's also this question is, does it need to be COAP S plus AT and COAP plus AT, or just one? Okay, that's another part of the detail to be worked out, right? So I'm saying we don't have to answer all those right now if we agree that it is not a deadline in this meeting, right? But I'm saying it is not a short set of details.
Yeah, as a redirect time, I think I'm okay with this being worked out in a separate document, as long as the working group is committed to actually doing work.
So can we avoid that being normative reference that causes the other document to be in the RFC editor queue for a year?
Yes.
Thank you.
That was Dave's point with having a forward reference, and my point with using updates to make that happen.
Okay.
Yeah, the other point is the irony of ISG started, can we have less URI schemes, please? And we ended up with more at the end. That's
Yeah. So I think that I'm not going to try to summarize it, but I think we have managed to find a reasonable way. So yeah. We unfortunately used the entire time we had in this slot. I just want to point out we have got work to do to make this new scheme, this discovery-based scheme work. There are two documents that are out there that probably would inform this discussion a lot. And one is the protocol negotiation document that was already mentioned, which provides one way of finding things, which is based on already being able to communicate using one of the ways and then finding other ways. And I'm going to skip through your slides, Bill, I'm sorry. So this is essentially an option that looks a lot like the alternative service approach. And the other point is, if we want to support this discovery, we have to provide the places in the discovery infrastructure that we are building to provide that information. Now, DNS already has service records, but if we are not using DNS, then we have to find a place to put that. The link attributes, which are now called target attributes of the link format of the resource directory, provide us with one way, and we probably should look into the various discussion documents we have to find out how we are going to use this. So again, look at the two drafts from Bill, and go ahead.
Hi, this is Bill from TUT. Yeah, the nice thing about IETF is that usually things proceed at a regular, reasonable pace, and then when it comes to the IETF meeting, suddenly everything happens. So these slides were prepared before we had the discussions with Karsten and a few others. So the reason why there are two drafts instead of one is that while the alternative transports draft, which was commissioned or chartered or requested for trying to identify the transport a co-op resource can be exposed with, can be done with a URI. We also noticed a similar problem about how to discover the multiple transport endpoints, and that's why there are two drafts. And these two drafts took a life of their own, but recent discussions for these two features were very useful. For alternative transports, what I'd like to say is that the current draft analyzes why you cannot put the transport information anywhere else than the URI scheme. It does not say why we need a URI. So that is something that the draft needs to do. And just before Karsten and I discussed about the CoAP AT, that was one of my compromises, that we can use CoAP plus AT for doing other things than the URI proliferation. And for protocol negotiation, for multiple transports, what I'd like to say is we're going to try to work on ensuring that we could use the document as a means to discover the multiple transport endpoints at the origin server with or without resource directory. Thanks.
Thank you. Okay, so we are about 7 minutes over schedule. Carlos, can you do your slot really quickly? So we are now in the section of documents that are close to getting working class call. So can you try to be done at 10:45 approximately?
Okay, so good morning. I'm Carlos Gomez, and I'm going to present the current status and the plan for the next update of the draft entitled CoAP Simple Congestion Control Advanced, also known as COCO. So let's take a look at the status of the draft. So the last revision is still 01, which is the one that was presented in Chicago. And after that, Jaime sent a heads up on this document before the intended working group last call. The heads up was sent to the core and TCPM working groups and also to the ICC research group. So after that, we received 2 detailed reviews, one by Michael Scharf, another one by Ingemar Johansson. So thanks to both for the very good and helpful reviews. And then we plan to update the document, hopefully addressing the comments we received. That would be version 02, and that version will be the one actually intended for working group last call. So let's take a look at the feedback we received and which is our position on the comments received and our plans for the updates. So in COCO, as you may recall, we are defining an RTO estimator, which makes use of strong and weak RTTs. So the weak RTTs are those that where the sender has run into retransmissions. So Michael had a comment that we would be possibly violating RFC 8085, which contains this statement that latency samples must not be derived from ambiguous transactions. However, what we are here is that we are not violating that statement because we don't use only weak RTTs. We have both strong RTTs and also weak RTTs, and possibly we maybe might need to make it clear that weak RTTs are actually needed in order to allow updating the RTO estimate in some specific conditions where otherwise it would be very difficult or even impossible. So some examples are links where there is high bit error rate, where maybe there can be intervals of very bad link quality with lots of losses. Therefore, there would be a high amount of weak RTTs there. Then another example is a network where congestion suddenly appears and then the RTT suddenly increases significantly. In that case, there would be spurious timeouts. So then the RTTs collected would be weak, and without using the information from weak RTTs, it would not be possible to actually update the RTO estimator to the new situation, leading to really bad performance. A possibly more extreme situation is that of a link or a path with a very large RTT, actually larger than the default initial RTO, and in that case, there would be always spurious timeouts, and without weak RTTs, it would not be possible to update the RTO estimation. So one thing we are considering is to make the impact of strong and weak RTTs something tunable. So currently what we have is that the contribution of the strong estimator and the weak estimator is the one that you can see on the slide, with a weight of 0.5 for the strong estimator, a weight of 0.25 for the weak estimator. However, we are considering to make this something tunable, for example, by using parameters, configurable parameters like the ones shown in red on the slide. And we would use as default values for these parameters, the ones we have been using so far, 0.25 and 0.5. So the idea here is to be able to tune COCO and to tune which is the impact of each one of these 2 estimators for the network where this is to be deployed. Then we received a number of editorial suggestions. First of all, well, the first is in the abstract itself, in order to make a bit clearer what we are doing in the document. Then we must admit that section 1 is currently almost empty, and we got a comment from both reviewers that there's content in section 2 that might be a good fit for section 1. Then in section 4, we have some text where we explain that in CoAP, there's application processing time that is relevant here for RTO calculations, whereas that would not be relevant for TCP. However, Michael had a comment that we might want to discuss the impact of TCP delayed acknowledgements. So we plan to incorporate this into the document and explain that TCP delayed acknowledgements may add typically delays of 200 milliseconds, even more in principle. And on the other hand, in CoAP, we have separate responses where delays of up to 1 second might be incurred. Then in the specific part of subsection 4.2, we have received the request to better motivate which are the properties and the reasons for the weak estimator. So we plan to incorporate this as well. This is reasonable because actually this is, as far as I can tell, possibly the first time that something like this kind of weak estimator is being used in the IETF. And also we've been asked to add a few more examples and even pseudocode to make it clear how the different steps of the algorithm need to be applied. Then we may need to add a few references to RFC 7252, mostly for readers that might be not so familiar with CoAP, with the terminology and also with details on its behavior. And then Michael had a comment about something that could be useful for the security considerations, that maybe an attacker might want to drop packets in order to increase the RTO and therefore degrade network performance. So this may be mitigated by network access control. And if the attack is performed by means of radio jamming, then we argue that the network may recover in a reasonable time if COCO is used, actually in a smaller time than that with default CoAP. And here again, the weak estimator would be really useful. So we plan to incorporate this into the document. Finally, on the appendices of the document, the first one is Appendix A, which describes an algorithm for aggregate congestion control. So this is an algorithm that was not so well evaluated as the core of the document. So our intention was to actually remove this part from the draft, and the feedback we received actually confirms this. So unless there are objections, we will remove this in the next update. And the other appendix is a summary of results and pointers to detailed documents with detailed evaluations. And the comments have been that this appears to be a useful appendix because it supports the mechanisms that we are defining here. So that's all, actually. I don't know if there may be any comments or questions.
Let's go to the next slot. Alex, Michelle. Which of these microphones actually works? Hello.
Good morning. First slide. Okay. I will start by a summary of where we had for about the COMI framework. We have 4 drafts. First one is the Yang to CBOR. So that's the mapping between the Yang data model and the CBOR encoding. That is stable for 2 IETF. We don't expect to do any more changes. So we believe that it's ready for working group last call. That's the question that will be asked by Alexander later during the presentation. Second draft is it's about the identifier used by COMI, the SID. That draft described the registration process. So right now we're working to establish a website for registration. So during that work, we might need to adjust the draft. So that work will be done between this IETF and the next one. So that one is not ready, but we're working on it. Next one, it's the protocol itself, COMI. We did extensive work, so I will thanks Peter van der Stock for all the help he did to bring that draft closer to completion. Well, I will go to all summary of all the changes we did. It's not ready for prime time, but I think all the technical content is in the draft. We just now need more reviewer. The last one, it's a data model used for application discovery, the Yang library. In Chicago, there was discussion about, is it in scope for core? Is it the right forum? So that's a question that will need to be answered. There's other data model in the queue, such as Event Logger, firmware upgrade. So that's something we'll need to decide. I don't know if the chair has some opinion about what will be the right forum for those data model.
Seems to work. So basically, I think we have tomorrow's meeting to find out what a good division of work would be here. So of course, we would be the working group to do MIBs for CoAP. So yes, fundamentally, it should be possible to do the kind of work here, but maybe there is another group that has the better experts for this. So let's find out tomorrow.
Okay. I just want to note that for the Yang library, is a reference in COMI for application that is a mandatory reference. So we'll need to resolve that. Yeah.
Yeah, this is Hank Burkholz. We are facing a similar decision problem. We wanted to start a COMI Yang module for software inventory. And we're also considering, are we going to NetConf or do we start this work here in core in the end? Because I think we're pretty sure that we know how to do the concise representation stuff, and that's all done. But we are not the NetConf experts, so to speak. And so we are actually considering starting that work in the NetConf group. And yeah, I think there should be some discussion on that. And I'm not sure if I see Mr. Misix at the table. I'm confused.
Okay, thanks.
Thank you.
Yeah, so the hard problem here is simply you need 3 groups of experts. You need people who know the Yang world, you need people who know the constraint world, and you need people for the specific subject matter, like your software identification and so on. So that's always a little bit hard to put somewhere. We will put it somewhere, and let's figure that out tomorrow.
Okay, now I will go to a summary of the changes done to the protocol document, COMI. First one is about the resource type. So we rename some of them so they are more obvious. So we have the resource type for the data store, for the data node, and the event stream. We also did some fix to the recommended path, so we don't have any more conflicts between data nodes. and event stream and URI. So before the stream was one of the data node, which is two different resources. Next slide.
Yep.
Okay, and next one is the introduction of content format. We have defined 5 content format. First one is to return values. Those values are, the encoding is defined in the Yang to CBOR draft. For each of them, we define the rule for delta encoding for compression. In that case, is the reference SID is the parent, and for the root it's in the URI. Second content format is an array of values that's returned by a fetch. Again, the delta encoding is the parent. Next one is for a data tree, so it's to return an entire data store. For that one, we had to introduce a new CBOR semantic. We call it right now order map. It is based on an array. Delta encoding is based on the previous sibling. Next one is the selector used by the fetch. It's an array of identifier. Delta encoding is sibling. And the last one is used by the patch. So it's an order map of instance identifiers. So instance identifier is a Yang data type used to point on a specific instance. So we have those lists of instance and identifier and the new value. When the new value is a null, it means deletion. If the value is not present, it's inserted. If it's present, it's updated. So that's all the methods supported by COMI and the associated content format. So for access to data node, we use values. Access to data store, we use trees. The fetch use the selector and values, and the patch use the patch. So that's a good summary of what COMI is. So all the different methods supported by COMI. The order map, we have a formal description of that semantic. We have requested a tag for it, a CBOR tag. We don't use it, but it will be available for other application. In our case, it's infer when we do the content format define if it's used or not, so we don't have to spend byte to put the tag. Okay, another area where we work a lot is the error handling. We clarified there's 2 types of error. We have the COAP error. We know we love or we hate, but all those error already defined in COAP. And we have error related to Yang, defined in Yang. For the implementation of those error, we use RESCOM as a reference. So on the left side, we have the payload structure of RESCONF. On the right side is the proposed payload for COMI. One modification we did is to remove the ability to return multiple error. In RESTconf, you could have a list of error. So in COMI, we'll return just the first or more important error. Also, RESTconf has this concept of error type. So it's really, it defines which layer of the protocol the error come from. In COMI, it's obvious if it's a COMI error or a Yang related error, so that field have been removed. The tag in RESTconf is implemented as string. We changed that to identity reference, identity ref, so it's implemented as integer, but any developer could add new error using identity, Yang identities. We did a change in the name of error path. We don't use path in COMI, so new name is data node in error. Not sure it's the right name. Everything starts by error dash and not that one. So we might revisit that name. And error info, it's an object associated to the error that can be returned. That have been removed. If people believe it's really needed, we could add support for it, but at this point we don't see much more need for that. So that's all the changes. Yeah, that name, not sure is right. Okay, that's the list of Yang error. Most of them are defined in Yang 1.1. Some of them are described in the text, but there's no tag defined. For example, not in range. In Yang, they say invalid value is returned if the range doesn't fit, but don't define any application tag for that. So we just define those tags, and since they're optional, people could use it or not use it. They could just return invalid value, or could return invalid value because of the range or because of the pattern. We went also through different RESTconf implementation, look at C code, and there's two other have been added, malform and duplicate keys. So that's the current list we propose. Developer could extend that list if people believe there's more need to be added. We just come and see us. So I'm done. So Alexander will continue. Any questions?
Thanks, Michel, for this. So as you see, we've done a huge amount. Michel has done a huge amount of editorial work, and Peter also helped a lot on this. So all these things that you see here, we agreed upon on the past IETFs. So as you see, it is simple to say, okay, introduce one content format so that we can introduce content formats so that we can distinguish between, you know, the different type of things that are happening, and then we actually get down to the dirty work doing. We end up with all these things, but right now it's pretty clean. So we have at least we know that we have 2 independent implementations as of today. Because there was some last-minute work, they are slightly incompatible with each other. There are really small, very small differences. So we have one implementation in Go, we have another implementation in C. And while we were here, actually, we discussed with other people, and we discovered that there are at least 2 other implementations out there. So we'll have like a week or 2 so that we can get synchronized with the small details that were the small deltas that are out there. And we are going to make an interop over the internet during in August, so that we are clear out that the things are working. And of course, we're planning to have an open source implementation that will be there for the next IETF. And the goal will be to have an interop in person in Singapore, and probably have a hackathon. So we're pretty happy with the things, the way things are working out. All difficult things are behind. We have few small details to figure out. And so the things that we have is, so here I think that maybe I made a mistake, and this is...
Yeah, before we go, a quick question. Who here is implementing some or all of this ecosystem? So I know Michelle is, Laurent. Okay, thank you.
Yep. So that's the first point. So as it is of now, we would like to go over this interop in the following month, so that we are clear that if there are any minor ambiguities in the text, that they are clear out, and we can go into a working group last call for this. So here I've put IETF 99, but I think it would be wiser to put it last call before the IETF in Singapore.
Well, whatever it is, I mean, it's 5 documents, so...
that's exactly on the COMI document. This is okay. Exactly on the COMI document. Yeah.
That still needs some time. Yes.
It still needs some time, and I would like to get over this interop process. As you can see, there are a lot of things that are actually coming from the Yang part of the things, the error messages and so forth. So this is why we're actually also going to be discussing a lot with the guys over there at NetMod to get input from there. So if there are no questions on this, let's move to the shortest presentation I hope I'll be making today. So this is the seaborne encoding of data modeled with Yang, which we consider very stable. There are no negative commands, no bugs, no nothing. So we have 2 options. Either we do a working group last call now, or if you would rather, we can wait for the comma interrupt during the summer and do the last call later, for this one and the comma together. But they are not, they can be independent.
So when is that interop going to be?
So the first one was going to happen in August.
Yeah, it's a long month. Starts with the 1st and ends
let's
with the
say
1st.
3rd week of August.
3rd week of August. Okay, that's about 4 weeks from now. So I think that sounds like a reasonable time to wait. But there is no other blocking on this document that I perceive. So I think we could working group call it now, but that would mean, without implementation feedback, that's not so bright. So I think it's better to wait for that round of implementation feedback and then go for working group call right there.
Okay, sounds pretty good to me. So we do the working group last call after the interop in August, right away.
So assuming we don't have to do major surgery on the document as a result of that feedback,
yeah.
We probably will find another T that needs to be stroked and another I that needs to be dotted. Mm-hmm. But essentially, we are last calling the document we have. Mm-hmm. While with the COMI document, I would expect the interop actually to bring up a little bit more stuff. So we will respin this document and it will be a little bit later in the timeline. That's my perception. Please tell me when I'm wrong.
I completely agree with you. So that sounds good. So that's the status of this document. And just to recap, like this gives you, okay, if you have a Yang model, how do you represent it in CBOR, right? There is the equivalent in JSON and XML, so nothing too fancy. Moving on to the Yang scheme item identifier. So this is also a draft where a lot of the things that are out there are pretty clear. So from the last time, we had 4 main topics: to clear out the definition of a SID, that it is a 64-bit identifier, to clear out the SID file format, the SID lifecycle, and the allocation policies. So since the last time, we've cleared out most of these points. The only small question is actually, I mean, we're pretty clear with everything the way it worked. We talked with Ayana, and everything seems pretty straightforward. But we really want to make sure that we're doing things the right way, and that there are no corner cases that we haven't covered. So I'm going to be talking about this on the next slide, and just to give you an update on the action points that we had since the last time. So things that we discussed in the working group, and that we said, okay, we will do the changes to the document. Modify the draft to introduce mega ranges, organize a meeting with NetMod through this IETF, and provide a Yang registration procedure. So the first 2 are done. Tomorrow we have a meeting, it's a side meeting, and there is a non-working group mailing list, so please subscribe to it, the Yang of things. Tomorrow we are from 10 to 12. I'll be talking a little bit more about this later, and I'll try to be really brief on this. And then while we were discussing the Yang registration procedure, we actually wanted to discuss something with you on this. And this is, we would really like to have this thing done correctly. So the things today, the way they are working today is we have these 2 registries. The first one is the SID mega range registry that is handled and managed by Ayana, that allocates blocks of 1 million SIDs to secondary registrars that we call the SID range registry. And then, of course, if we want to have the very, very good and very nice quality of introspection, it is good to have a Yang registry. So the SIDs are actually where you allocate the numbers, and then you have another registry that you keep the Yang files, so that whenever you have a number, you can actually find out, well, what this number tells you, what it does represent. And the way it works today, so the workflow is, as an end user or developer or whatnot, a Yang module developer, what they will typically do is, well, they request a SID range, they get allocated this SID range, and then they go on their daily lives in developing Yang modules and so forth within the SID range that was allocated. And so that's really cool and neat, but as it is of today, there is no really implicit way of actually making people share the Yang files, right? Other than, okay, it's really good for the community and for the society. Well, it is up to their discretion to go there and publish the Yang file that they did. So that's one thing, and we could keep it as it is. We would like, so that, and it's really good for private module registration, right? This is a must. This is a must because people, they would like to be able to register private Yang files for their internal consumption. Now, the things that we would like to investigate without slowing down the document, and we would like to get into our thought, is how can we incentivize public Yang module registration, where we have this link where you develop your Yang module, and there is an experimental range, and then you basically push it to some public registry. It can be Yang catalog, it can be something else, and then you directly get the SID file with the allocated directly from there, and so then the public can, anyone can just go there and look up from the SID the Yang file, and it will all work out pretty well. So this is like a slightly open question. How do we do it? And of course, there are things to discuss. What we would like to do, and the way we are actually addressing this question, is to say, well, today we have on implementation of this registry, of the Yang registry. We have a Git repository. And by the end of August, so this will be for the interop, we'll have a running SID registry that you can go and you can, you can request your SIDs, and so we are able to do this interop meeting. And the proposed action is that we would like to encourage this one-step registration, where you come with a Yang file to a public registry, you register it, and then you get everything out there. And probably also include some parts in the SID file that as it is of today, so that we encourage this introspection way of working, like an URI pointing out to some permanent place where you can find actually the Yang file, maybe add some hash that you make sure that this is the Yang file you're talking about. So our proposed plan of action is just slightly modify the SID document as it is of today, so that we don't block one-step registration, which could be added in a second document in the future in case there is a need to.
Thanks a lot, Alex. This is Pascal Thubert from Cisco. Quick question about the when you have an item which is defined multiple times in Yang, like MAC address or whatever, would you recommend that there are as many SIDs, or would there be a way to, or desire to have single SID for multiply defined objects?
Oh, okay. So if I try to rephrase to see if I got your question, is if you have some given type of something, would we encourage people to say, okay, don't reinvent every time the notion of MAC address. Try to go to the module that once defined it and then just inherit from it and reuse it.
This is already done.
Yeah.
So taking the fact that things are defined multiple times, what is the optimal design? Like, since the SIDs are not really allocated there, you will have to define this policy. And if you really want to do flow 2, at some point there will be some magic which will go from the repository, the Yang catalog, and fetch SIDs. And people will build some automaton for doing this. And I was just wondering, if we just let them pick things serially, then we'll get as many SIDs as we get multiple references of the same type. Whereas, would that be desirable, that basically the SIDs can act as correlator of types, which are identical actually, but multiply defined? Just
okay. So I see what you're saying, and this is actually why I really wanted to have this discussion. And I love your comment, and I think that we should take it into account. So the question, if I get it correctly, is okay. Here you have a developer that publishes a module, and this module is not something that is on its own. It inherits from other types that have already SIDs that are allocated to their other things. So this Yang registry, instead of just going and fetching new fresh SIDs for things that are already have allocated SIDs, so this thing could actually go to the SID registry, and the SID registry can do some introspection and can see, oh, okay, by the way, MAC address already has a SID that has been allocated. So I think that's an excellent question. We have lots of SIDs, so that's not the problem, but the problem is that we make sure that we don't redefine, like we don't end up with multiple SIDs for the same thing. I think that it is possible to do this without actually to do like a best practice for this. So in theory, it could be, both could be done. I would be much in favor of what you're saying, that we make sure that always the same SID is used. So if you're using a MAC address, it's always the same SID for this MAC address if it is the same module.
But
yeah. Okay, I think on the manual.
So Juan Carlos Zuniga, Sigfox. I have a different question, but just to follow up on this, would that mean human intervention or automatic discovery of what exists in the world?
Pascal, it's just that we are at this very, very cool place where nothing has been done yet to do this flow that you represent here. So I would just suggest that instead of just doing it blindly, we care about what kind of result we want to achieve. And it's already the case that MAC address is defined in tens of models. And so depending on what the desired effect, we should define whether an SID, or it's hopefully an SID points to multiple is one-to-one, because the use of SID later will really depend on that discussion. And what I expect, yes, it's going to be automated. There won't be a manual. The whole goal of this design, there won't be a manual intervention. Somebody will write something, and then it will run all night through the catalogs and get a result. And we really, really care about what this automaton will be doing, because all the use of SIDs in the future will depend on what that automaton will have done that day, because after that, it's history.
Completely.
Michel Veillette, I'll try to answer that question. SID are assigned to Phil. Phil in Yang is called data nodes, so not to data type. So let's say you have a data type that define an IP address and use for setting your DNS or using the interface. The SID is assigned to that usage. So the IP address of your DNS or your server, your interface. And the Yang define those data node, and we just map SID to each of them. But if you have different Yang file that set up DNS differently, this will be a problem. But if everybody use the same data model, the same Yang file for setting their DNS, there's no issues.
Yeah, I think we will have tomorrow to get to questions like this. Juan Carlos?
Well, Juan Carlos Zúñiga, Sigfox. Just a quick question. Coming back a little bit on your slide, I think you answered it. Just want to make sure that it's clear. So you are not saying public versus private. You are saying let's start with public and then we go for the private. It's like a two-step approach, not like one or the other.
Yeah, it is a two-step approach. Let's start with this one because it is already there and we know that it is not blocking because industry. So we got input from industry and people want to be able to register private modules.
Okay.
And it gives you the option to actually go to the public one. And the idea is, let's maybe add a minor thing that allows introspection. So whenever we want to go to a public one, then we are not blocked with it.
Okay,
thanks. So, and move on, because we are ready now to do the implementation of this, and we have something that we did it manually for the moment. So now we want to build actually the software that allows you to automatically do the registration. So let's move with this one. And, at some point we decide, okay, do we close this document and maybe say, okay, set public registration BCP or something. But that should, I think we can split the two process.
Right. So I think that's as far as we will get today. Again, we have tomorrow to go into more details. So I would actually like to cut short the agenda item right here.
Okay.
So we just go to the next one. I think on Friday we will get a quick report what happened tomorrow, so we can react to that here. Okay.
Okay. Do I say a word about the Yang of Things, or?
Well, that's the ad that we already had. So there will be a Yang of Things meeting, and those people who are interested in managing constrained nodes may want to go there. And the room is way too small, so come early. Okay, so we have 3 more items on the agenda, which are hopefully quick items, but...
Hi, just a short intermediate comment for J. J conflicts with FAD.
Yes.
So this is, most FAD people want J. And
yes, so just don't go to the FAD meeting, go to the J meeting.
No, we'll go to second, but that's another thing. So.
Sorry about that. Yeah, conflicted in IETF are brutal. Jari? Oh, you just have one slide, so you don't need a controller.
So my name is Jari Akko. I'm here to talk about device URNs. This is a draft that has been recovered or reissued after years of being not being updated or discussed. And the reason for the update, first of all, I was busy doing some other things,
But now I'm back in technical work, so that's one reason. The other reason is that there was actually people who were saying that they are using these things in production systems in large scale systems, and that might be a reason for us to actually complete this process. There's also a reference from the CNML document to this document, and some examples, which of course could be changed or replaced with something else, but that's another sort of a editorial reason perhaps to do something. So these are essentially identifiers, or it's a namespace for pointing to hardware device identifiers, and it's complementary to what we have in some other URN types, either with other hardware identifiers like IMEIs or then other types of identifiers like NIs and UUIDs. And what we do here is essentially define a way to refer to currently MAC and one-wire identifiers, but it could also be extended to do some other things. And it's mainly targeted for things like hardware registries or equipment inventories, but also sensor data streams that this reading came from that sensor, that sort of thing. There's an update of the draft as I submitted it. There's another update queued up, not completely done yet. That would have to deal with the new templates for URN registrations, among other things. I also want to update the security considerations section. So it's fine to put things like hardware identifiers in your own database or equipment inventory and such. You should probably not spread them all around the internet, without thinking about that. So that's a consideration to be added. And I guess the main question is there interest for this? Could we make this an RFC finally? Interest from the working group or interest from the IETF in general, and also soliciting comments either now or later on the actual contents. That's it.
So Tim Karinioki, I will say that we actually use this in 3 different SDO bodies for pointing to device identifiers. So if there's a mechanism to make this an RFC, I think we would fully support that because we use them. Is the intention to expand it to additional identifiers?
It has the capability to be extended, and the syntax is kind of obvious in that sense. But it's up to whatever
I mean,
people want to
in
do.
the new drafts that you're dealing with.
I'm sorry?
Is there opportunities to bring in new identifiers in the drafts that you're referring to?
I mean, this would be an opportunity. If you have some specific ones, we could add things now, or we could add things later.
All right, thanks.
Thank you.
Hi, this is Henk again, and this is now my Trusted Computing Group head on. The Trusted Computing Group is watching this stuff carefully. So,
in a positive or negative?
In a positive way, because they have a lot of identifiers. Most of certainly the attestation identification key. And so, we would like to see a specific, integration of that. Be the TCG, basically. Because maybe we should talk some more about this, but if we're going, because finding identifiers or identities, that's slightly different now. It's kind of hard, and they have a complete semantic OID subset. It's not registered yet for partial identifying attributes and such. Maybe we could talk about this a little bit.
Yeah, it sounds like a topic that needs sort of further elaboration.
Yeah.
I mean, this is not the only possible way of doing identifiers, obviously. So
I know, but this is one
and,
thing that is interesting. And also, I think that TE, but I don't know if Hennes, T guys here, they're also very interested in talking to the right TE and identifying those.
Right. Okay. If you can post something on the list, then we could discuss.
Dave Taylor. So I think this is a good idea, but I think that the first sentence there, a uniform resource name namespace for hardware device identifiers, I don't think that's what you're doing. I think what you're actually doing is hardware device locators, not identifiers. Okay. So because if, some hardware devices have more than one MAC address. Okay, and so we had the discussion before about URI aliasing, and so these are locators, not identifiers. And so I still think this is a good idea, but I think if you actually want a unique identifier for a device, then you might be using something like the hash of your private key or public key that was generated by your TEE, for example. And if you've only got one of those, even if you have multiple MAC addresses. So this is useful for device locators, yes. I don't know if it's useful for device identifiers. And if you're using it for locators, then that goes back to the question we had before, is why are you using URIs as the syntax for locators?
Yeah, so I guess the use cases that I've seen for this involve not necessarily identifying exactly where you are in terms of the network, but rather just registering a particular pointer that indicates that it's this entity. We have other URN types for hash or public key based identification, which can be used, and we have UUIDs. These are a little bit more straightforward identifiers of hardware identities, which I think is useful even if you have those other capabilities. We could talk about the exact way that we describe this. That's your comment, Dave. But anyway, yeah, maybe need more discussion.
Hi, this is Hank again. I'm just quoting RFC 4949, and an identifier as a data object that definitely represents the specific identity of a system entity and distinguishing that identity from all others. So, what?
ID locator is a set of terms that many people in the IETF use for things that are sort of unique and stable, whereas locators are things that may change, or that you may have multiple of them, or both of the previous two conditions, right? So if you have multiple MAC addresses, it's a locator in that sense. If you have multiple identifiers, okay, like multiple MAC addresses, then you have multiple URNs, and it's the URI aliasing problem that we talked about before. Okay, which is you have two sets of, for example, sensor readings because they came from two different MAC addresses, or because you switched the MAC card on the machine that it's coming from. And I'm using that as an example, using terminology from a much bigger class machine than a sensor, right? And so trying to correlate that is the problem.
Great discussion to be continued on the mailing list. We are really at the end of this segment.
This is Barry Lee, but we just quickly on that, we have many situations where things have multiple names, and I don't think that means that the names are locators necessarily. My question, Yari, I'm sorry I have not read the draft, so you can answer this relative to the draft, is the third thing there, which in your examples is MAC and OW, intended possibly to be delegated to some other organization to allocate below? So for Mac, your thing has a MAC address, and you can construct the URN and you know what it is. But perhaps in other cases, you would need to go to another authority to have them allocate a URN for you or something. Is that intended to be a possibility?
Well, it's a syntactical thing. We could have defined a MAC URNs, but we wanted to do device URNs, and then under that have another layer where we can sort of select, and then we can perhaps later extend in various ways. But there's another question of like who's responsible for the actual identifier space. And in this document, at least for the two cases that we have here, we've been very clear that we're not responsible for that. It's those other guys over at IEEE, for instance, and so forth. So we are only sort of referencing that space, not claiming that this document or IETF or anyone, because of this, has jurisdiction over those numbers. We're just referring to.
Right. What I'm getting at is, so now today, someone can come and say, I assign Bleegs. So I want URN:Bleeg, and I will assign them. Could someone come here and say, Bleegs are device identifiers and I assign them? Could I get URN::dev::Bleeg and I assign below that? And do you envision that?
That's a good question. I think we should allow that, but the draft currently doesn't have text that would talk about when that's okay, because probably there are cases when that's okay and when it's not okay, right? So we should develop that.
Okay, thanks.
Alexei Melnikov. Subject to more confirmation, and there is interest in this, and I think they seem to be, but I just want to have a bit more confirmation. I would be happy with either working group document or AD sponsored by me. So,
thank you.
But it seems to have a little bit of work needed.
Some discussion is indeed needed.
Okay, so given that, I'm not going to ask the question whether the working group is ready to adopt that right now. But I sense there is interest in the room, and I sense it meshes very well with the other things that we are doing, in particular cinema. So I would expect us to pick that up and not push it away to somewhere else. Thank you. Christian?
Hello, my name is Christian Amsus, and I'd like to present a document which deals with some open security problems that occur both in OSCOAP and with DTLS. Next slide, please.
You are in control.
Yeah. This document has a history of being published as separate documents. There has been John and Göran's CoAP actuators document that describes some attacks and an option that mitigates them. I've submitted a core request tag which describes another set of attacks and a solution to them. And what we've been doing in the last editing stage of this is pivoting this to have a problem statements document, which is not updated yet, and a joint utility options document that will help mitigate those attacks. The first issue is freshness. Both DTLS and OSCOAP provide only relative freshness in the sense that you know that a request is earlier or later, but you don't know that this is still current. The kind of typical example is unlocking some kind of lock. The attacker swallows that package and retransmissions. The user goes away and the attacker later replays that package, which hasn't been seen by the server, so it's kind of fresh. The proposed solution is to have an option, however we will call it. Right now it's called repeat, but we are open for suggestions. That says, client, your request was noted, but I won't act on it unless you say, I am the client and I'm still ready to do this, which is expressed in a short nonce that the server generates at random. And when the client can repeat that, the server will know that the client has, between the first and the second submission, at some point in time been interested in changing this. The solution also has applications in OSCOAP where we can use it to synchronize state, which we'd otherwise need to carefully keep track of. But unless there are questions about that, I won't go into much details on the other applications. The other issue is the correlation of the various parts of a blockwise transfer. To shortly repeat, the various parts of a blockwise transfer are not strongly linked together, which is a good thing because this allows us to do kind of random access on CoAP resources, so you can fetch a particular block and just get that back. But in the context of having a body that is sent with the request, this means that the server can never be sure whether those blocks are actually linked together. And I'll, in the next slide, explain a slightly convoluted but example of how this can be used in an attack. This is a situation that usually won't occur naturally, so it only comes up in the security context. The solution we're proposing is to have a tag in a shape similar to the e-tag that is generated by the client that can be reduced under some conditions that are defined in the document. So the overhead can be kept low because the tags don't have to become large. They can actually stay absent. And if that option is applied correctly, the server can be sure that the complete body it has assembled from several block requests is actually a body that the client intends the server to process. And again, this has different uses as well. When it is implemented in proxies, they can process different clients' requests to the same resource more easily without having to complete one before finishing the other. I've presented or actually Göran has presented the attack that outlines the situation before. If you have say a firmware update consisting of only 2 payload blocks, and the first upload is taken by stored by an attacker and suppressed, a later update could have that block injected, and then the server will receive a request body that has all its parts correctly signed by or correctly macked by the client, but still would assemble something that will fail to perform, will corrupt the device whatsoever. And the request tag option is a way of dealing with that. So there are two questions I would like to ask, and 2 more that are the classical questions. One is this describes how the server reassembles the packages, the request blocks, and it may be a good idea to have this update the blockwise document so that all servers need to process that. Otherwise, the client will just see that the server has an option it can't process and will be unable to do that secure operation. The other question is, are there any even more lightweight alternatives we did miss? One option would be to integrate with sequence numbers more deeply. The tricky part about that is to be sure that random access to resources still works when the server supports it. Yeah, and the remaining questions are, who has read the document, who has feedback for us on this, and how can we proceed with that?
Yeah, so who has read the document? The authors have read the document, that's good. And a few more. Okay, a few more, actually. We have discussed this set of problems a few times here. So just to verify, of the people in this room who think they understand the 2 problem statements that underlie these 2 mechanisms. Show of hands, please. Okay, so that's more like 20. So we do understand the problem statement, and who has at least read a version of this document to have a rough idea that this is going in the right direction, solving it? Okay, that's the same people again. Alex suddenly hasn't read it anymore. Okay, this is a little weak, but we will confirm it on the willingness anyway. So I ask it anyway. So of the people who know something about this document, who thinks this is the solution? Excuse me. This is the basis for the solution that the working group should work on to solve these problems. Skip the question, should we solve these problems? Okay, that's about the same set of hands. So I think we do have in-room consensus. It's not very strong because it's a small group of people, but we will confirm it on the mailing list and send the confirmation call. Oh, thank you. And please fix the name. Michael.
Hello everyone, Marco Tiloca from Rise 6. I'll give you some quick update about how to use OSCOA for securing co-op group communication. This is the overall set of related works to this draft over different working groups, and this specific draft takes place over there. Just to give some quick background, but we went through that any other times, of course. OSCOP is used at the application level to provide end-to-end security between a co-op client and server, referring to security context. Some of it common, the other part is sender and recipient split. There's bind between request and response, and selective protections of parts of the co-op messages. So this draft is about adapting OSCOP to be used in a group communication context when you have a number of nodes acting as multicasters, so sending via multicast IP requests to the listener in the groups that can in turn reply back with unicast responses. There's again binding between requests and responses, same security assurances, including source authentication mandated in the draft body and enforced through asymmetric signature. And as you can see in this example, at least, a node has in general a common context, a sender context to protect outgoing messages, doesn't matter if they are requests or responses, and then a recipient context per endpoint from which a message is received. And recipient contexts are derived runtime when it's needed. So the first time a message is received from that endpoint. This is version 0.2 right now. Main features very quickly, same security requirements of OSCOP fulfilled. As I say, especially source authentication through asymmetric signatures, and we go for source for counter signatures embedded in the COSI object in the countersign field. And this is all based on an entity name group manager responsible for the group, especially for the sake of the actual join process of new members of the group, and for handling, revoking, renewing the key material in the group. And it's up to the group manager also to assure uniqueness of endpoint IDs within the same group that it manages. The updates from the previous version are quite many based on many reviews we got, actually. Thanks all the reviewers for that. This is aligned with the latest version of OSCOP, of course. We have introduced the new concept of pure listener. Thanks, Jim. Shout about that, by the way. So it's a special listener node that doesn't reply back to a group request, but simply receives them, verifies them, and takes some action if asked for. Such a node is especially, of course, easier to initialize and manage in case. So, of course, we revised the security requirements and the security context, especially in the presence of this new kind of node. Some additional considerations, quite detailed, I would say, on the context ID, and we indicated as mandatory to implement ED 25519 as the signature algorithm to consider. Also, we described a line again with OSCOP how to represent the compressed COSI object, and in doing that we are now using also the countersign field that is not used in OSCOP, and we have introduced a new group ID field to indicate the context ID to be considered. We also extended quite a lot the security considerations, especially for the sake of synchronization with sequence numbers in the group, and that applies for nodes that have just joined the group, or for nodes that for any other reason can lose synchronization with sequence numbers, for instance, in case of reboot or any other reason. We also revised a bit the mechanism for public key provisioning to nodes that join the group. For the synchronization issue, by the way, we are referring, of course, to the graph just presented before. That's preferable approach. Also, we added 2 brand new appendices, suggested alternative modes that are not part of the main specification body, but still someone showed interest in having them. The first one, Appendix C, is about how to shift this approach to purely symmetric solutions, so without asymmetric signatures. And that can be the case for some use cases with particular requirement like low message latency. In Appendix D, instead, I guess that is also after Jim's comment. We describe how you can preserve source authentication through digital signatures, but instead messages are not encrypted any longer. So that allows proxies for something more. So they can still inspect and process messages and aggregate them without really changing them. We decided it's better to discuss that in this very draft, even as an appendix, because it's this draft that introduces the use of countersign field of the COSI object. We have also finally a first proof of concept implementation up and running in Contiki, tested in two platforms, Wismod and SmartRF. It's available on GitHub, and as related next steps, we want to keep this especially harmonized in details with latest scope, especially as to the compressed COSI object. Check alternative ways to compute digital signatures in hardware, at least on the SmartRF platform that allows that as an alternative to software computing of digital signatures, and start to produce some preliminary numbers out of experimental evaluation. We have also related activity to this draft that we have recently submitted to ACE. The problem is covered in Appendix A of this draft following a discussion started at IETF 97, and it's about the specific problem of joining the group, essentially interacting in a secure way with the group manager. So it's briefly discussed in Appendix here, but we have a proper draft in ACE describing how the group can be joined, interacting through the group manager, having in a nutshell the joining node acting as the ACE client and the group manager as the resource server. And the details, especially as to the secure communication with the group manager, are actually up to a specific ACE profile you decide to use for that. So to wrap up, again, this is the result, version 2 already, of many comments we got and integrated from many reviewers, especially Jim Schaad and Klaus Hartke, among others. That's again a summary of updates I gave you in the previous slides. We have a first proof of concept implementation up and running that we intend to refine and use for first benchmarks. And we believe the document is quite in a good shape to be considered possibly for working group adoption. Thank you very much.
Dave Taylor, this looks like really good work. Thank you.
Thank you.
Just have one follow-up question. You talked about the addition of the pure listener. So in the 7390 or whatever it is, that's the group communication for CoAP, that one only uses the ASM model. Now that you have the concept of pure listener, I wonder if this is also now potentially applicable even to the SSM model, where you have everybody as a pure listener except for one node. So my question is it actually potentially applicable, more generally applicable even than 7390?
I think so. In the case, for instance, you have one multicaster that, well, if it's the only one really, that there's no need to have any other multicaster, and then, yeah, the pure listener simply receive and never reply.
Yeah, because certainly there are use cases in IoT for things that you have one privileged, beamer of information and a bunch of subscribers that are unprivileged or whatever. That's an interesting IoT use case for, advertise, supermarket end caps or whatever it is, right? And so, if so, even better, yeah, so.
Thank you.
So who has read a version of this document? Pieces? So I'm seeing about 10 hands. Of those people who think this would be a good basis for doing work on this? That's fewer hands. Am I really seeing fewer hands there? So who does not think it would be a good basis for doing work on this? Okay, maybe I'm just not having a good vantage point here. And who thinks this is a problem that we should be working on? Oh, a lot of people think that. Okay. So again, as I believe this is very clearly within our charter. I'm ready to be corrected.
Yeah, don't ask these questions yet.
Right. So we have in-room consensus that this should be adopted, and we will confirm that on the mailing list. Thank you.
Thank you all.
Okay, and we're at the end of the meeting, 1.5 minutes early. Thank you. See you on Friday.
We're having lunch now.
Yes.
Where is trying to kill us.
Absolutely.
So don't take anything as the latest in the working group, no matter whether you think it's a good idea or not, until this is resolved with the
Yeah, we can.
There is no point because if it's already a train wreck, it might just become worse. So, and this is purely political thing.
Yes, absolutely.
Yeah, lateral. Yeah, exactly.